Hey guys, welcome back. You should have watched the preview on literal equations. Now we're going to go through and start to fill out the notes. So, a literal equation is an equation where variables represent known values. Literal equations can use letters for both constants and variables, and a formula is a kind of literal equation. So, thinking about it, if we decided to have, say, an equation with just shapes, okay, in this case we have a triangle plus a circle minus a star equals a pentagon. Okay, how would we solve for just the triangle? Well, our whole goal would be to get the circle to the other side and the star to the other side of the equation. Okay, if we did that, if we add a circle, the opposite or the inverse operation would be to subtract a circle. Okay, so when we did that, we'd bring it to the other side as a minus circle, and then for a star, it's minus a star, so the inverse operation would be to add a star. Okay, so if we solve for the triangle, it would become the pentagon, okay, pentagon minus the circle plus the star. Okay, so we solved for the triangle. Okay, in the other example we have, we want to solve for the circle. Okay, well, in order to solve for the circle, we've got to get it by itself. So it looks like we have kind of a fraction bar. We're dividing here. So if I took both sides and multiplied them both by a triangle, the triangles on this side would cancel out. Okay, and then all I have to do is take the star to the other side. So this is a positive star, so I would just have to subtract the star. So we would end up with a pentagon times a triangle minus a star, like that. Okay, so that would be our solving for the circle, would be the pentagon, okay, times the triangle minus the star. All right, so that's kind of confusing with the symbols, but how are the above examples similar to solving equations? It's just the golden rule of algebra. Whatever you do to one side of the equation, you have to do to the other. So whatever you do to one side of the equation, you must do to the other. All right, so I think that when we start to actually do some of these, they will seem easier. Do it to the other side. Okay, so for instance, example 1, we want to solve for y. So our whole goal is to isolate the variable, get y by itself. All we have to do is subtract 3 from both sides. Okay, and this is similar to what we did when we solved. This is solving an equation. Y is equal to 10 minus 3 is 7. So that would be our answer. All we do is subtract 3 from both sides. Okay, but now example 2 has 2 variables. Okay, we still want to solve for y. Okay, so our y is on the right. Now, it doesn't matter. You can rearrange the whole entire problem and get y on the right, or you can work with y on the left. Or you can work with it on the right. Okay, in this example, I'll keep it on the right. My goal is to isolate it, so I'm going to add 3 to both sides. Now notice, 2x and 3 are not like terms. So I'm going to rewrite this as 2x plus 3 is equal to y. Okay, now your variables should be on the left, so we can rewrite this as y is equal to 2x plus 3. Okay, so I had said before I could rearrange the whole thing at the beginning. So if I had 2x is equal to y minus 3, I could just start out and say, well, that's the same as y minus 3 is equal to 2x. Okay, just like I did in the intro video. You can just flip, okay, the order there. And then when you add 3 to both sides, okay, you end up with y is equal to 2x plus 3. Okay, same answer. All right, so let's try a few of these. Okay, so now I'm solving for y. So my y is already on the left. Okay, so I want y to be isolated. So I have another term here. I have a plus 1. So I need to subtract 1 from both sides of my equation. When I do that, I end up with 2y is equal to 4x. But now my 1 is a like term with the constant 7. So 7 minus 1 is 6. Okay, and now I've got 2y is equal to 4x plus 6. In order to get y by itself, I need to divide by 2. Whatever I do to one side of the equation, I do to the other. So y is equal to 4x plus 6 divided by 2. But notice this fraction. I can actually split this apart to 4x divided by 2 plus 6 divided by 2. So this would become y is equal to 4x divided by 2 is 2x, and 6 divided by 2 is 3. So we should end up with y is equal to 2x plus 3. Okay, so let's move on to the next one. All right, so now we're going to solve for y. Okay, now y here we've got a fraction. Okay, to get y by itself, we need to get rid of that 3. Since we're dividing by 3 on one side, we can multiply by 3 to get rid of the fraction or the division. It's the opposite. And if I did that, this would become 3 times 2x is 6x, and y divided by 3 times 3 would just be equal to y. So then I can rewrite this as y is equal to 6x. Okay, moving on to number 5. All right, now we want to solve for y. Okay, I've got another term on the left side of the equation, this plus 6x. So the first thing I'm going to do is bring it to the other side. So I'm going to subtract 6x from both sides. All right, when I do that, I've got 3y is equal to, and these are not like terms, so it's negative 6x plus 12. And now to get y by itself, I'm going to divide by 3. And since I'm dividing every term by 3, I can either split it apart. I could say 3 divided by 3 is just y, and then I've got negative 6x divided by 3 plus 12 divided by 3. Okay, or you could just jump to negative 6 divided by 3 is negative 2x, and 12 divided by 3 is 4. Okay, so we end up with y is equal to negative 2x plus 4. All right, number 6, we're solving for y. All right, so I want to multiply both sides by 4 to get rid of that fraction, but I've got to be careful because I don't have any parentheses here, so I've got to make sure I distribute that. So I'm going to put the parentheses around it, and then I'm going to distribute. So we get 24 plus 4x is equal to, well, those would cancel out, our y. So I'm going to rewrite that as y is equal to 4x plus 24. Okay, so at any time, if you want to try to stop the video and try a few on your own and then verify that you're doing it the right way, that would be great, but I'm just going to continue on here. So number 7, we're solving for r, and this is important. You might want to always circle the variable you're solving for because that's the variable that you want to isolate. When you have r right next to t, that means you're multiplying. The inverse operation of multiplication is division, so I'm going to divide by t. Okay, t divided by t cancel out, and I'm left with d divided by t is equal to r, or rewrite this as r is equal to d divided by t. That would be our answer. All right, number 8, we are solving for c. Okay, so we've got our c. So in this case, we've got the other term 2b. So the first thing I want to do is bring the 2b to the other side. All right, so I end up with a negative 2b plus ax is equal to negative cy. Don't drop the negative, that's already there. We didn't change that. All right, now we're solving for c, so we're actually going to, since we're multiplying a negative 1 times c times y, we're going to divide both sides by a negative y. Okay, notice I'm doing it for every term. Okay, so when I do that, I've got negative 2b plus ax divided by negative y is equal to negative c. So that cancels out, and I'm left with c is going to be equal to, we're going to take the 2b, negative 2b plus ax divided by negative y. Okay? So there's our answer. Okay, moving on to number 9. Solving for m, we want to start by subtracting. Okay, we're going to subtract 4k from both sides. So we're going to be left with mn is equal to negative 4k minus 3. All right, so now we want to divide both sides. Since we're solving for m, we want m by itself, so we're going to divide by n. That would cancel out, and we're left with m is equal to negative 4k minus 3 divided by n. All right, now keep in mind some of you may have different orders when you do it, so you might get something like this, m is equal to negative 3 minus 4k. The terms may be switched around, that's fine. Okay, that's fine too. All right, if I look at number 10, we're solving for y, so I need to get rid of the other term first. I'm going to move that to the other side. I'm going to be careful because the other side, they're not like terms, so and they would cancel out here, and we would get a negative 10x plus 30. And then we're going to divide both sides by 5. Now, if you want to take each term and divide it by 5, that's easier for you. That's fine too. So that would cancel, and we would be left with y is equal to negative 2x plus 6. Okay. Number 11. We want to solve for x. So in order to get x by itself, we've got to multiply both sides by p. Okay, because p divided by p is 1. So we're left with pm is equal to x plus n. Again, we're solving for x, so we just need to subtract our n from both sides. Now, these are not like terms, so pm minus n is equal to x. Or I can rewrite it as x is equal to pm minus n. Okay. Number 12, we have a is equal to 1/2 bh. Okay, we want to solve for the height. Okay, so we want h by itself. If they're all close together, remember that's multiplication. Now we have a fraction, so we want to get rid of that fraction. Okay, we want to bring it to the other side, so we're going to do that by multiplying it by 2. 2 times 1/2 is 1. Okay, so we're left with 2a is equal to bh. Since we're solving for h, we just have to divide by b. So 2a divided by b is equal to h, or we can rewrite that as h is equal to 2a divided by b. All right, 13, okay, we're solving for x, okay? So again, we have a fraction, so we multiply both sides by 4. Again, the multiplication property of equality works the same for literal equations as it does for regular equations. So we're left with 4y is equal to x. All right, or we rewrite this as x is equal to 4y. And then in number 14, we solve for y. So we're going to take the 20x and move it to the other side, and we're going to do that by subtracting 20x on both sides. Okay, when we do that, we end up with negative 10y is equal to, oops, hold on a second. Negative 10y is going to be equal to, oops, I am making a mistake here. Go back to this one here. All right, so this is an equal sign. It's looking weird on my screen. So this is actually an equal sign. 20x is equal to 10y, okay, minus 30. So if we want y by itself, we're actually going to start out by adding 30 to both sides. Okay, so we're left with 20x plus 30 is equal to 10y. All right, and then we want our y by itself, so we're going to divide everything by 10. So this could be 2x plus 3 is equal to y, or y is equal to 2x plus 3. Okay. All right, so at this point, I know we went pretty fast. I want you to try to look through it and go on to the homework. Okay, if you need help with the homework, I'll put out another video to help you walk through the homework, but I want you to try it on your own first.